Hi, I'm Leonard Facchinetti. Let's write some code together, shall we? I'm on the other side. Isn't that weird? That is weird. So this is what's going on. We are writing this JSFX library to do real-time audio processing in REAPER and help other developers write their libraries. And this is what's up. We have this component that draws the waveform on the screen. And this is the waveform of my microphone in real time, which is super cool. But it doesn't really work. You see that spike? That just went by? That is not right. And when I put two of these, because this is a stereo signal, though the microphone is mono, it's actually sending two tracks of audio to REAPER. See that spike? That's not good. Another spike and another spike. When I put the two on the screen, it's like glitchy as hell, and it even affects the audio. You can see some spikes in the audio as well, which is kind of weird because on this effect, we are affecting the audio just with a delay. It should not be doing that kind of spiking. And at some point, it did that before. It may even like send a super loud bleep, which hopefully is, you're not hearing this audio, okay? You are hearing another REAPER instance with my audio. In any case, that's a bug. There is a bug somewhere in this component. And today we are going to find out what the bug is. I have a suspicion. Last time, it was Tuesday, I was working on this together with you on the stream. And I noticed this problem, and I think I know the solution. I think I know what the problem is. It's super glitchy. It's flickering on the screen. It's crazy. So I think that the problem has to do with the following. Let me open up the JSFX documentation. The way that this visualization works is we have some, oh, see, it clipped. It was off the screen, unfortunately, but it clipped. We can see the issue. So what's going on here is we are collecting samples as they come in. We are collecting the audio signal. Then we copy the audio signal into a temporary buffer that we render on the screen. And the reason why we do this with the temporary buffer is so that if the drawing on the screen is happening at the same time as the collection of the samples, because new samples are coming in as we are drawing on the screen, and these two things happen simultaneously. If that's the case, then we are going to work on the copy that we made, which hopefully will not be affected by the samples coming in. So it was supposed to avoid these kinds of visual glitches, but in fact, it may be causing the visual glitches because in the documentation, they say that there are a couple functions, it seems like 4 functions, that cannot cross this boundary in memory. So the addresses in memory need to be aligned so not to cross these positions. And the functions that care about this is the MDCT, which is a discrete cosine transform. We are not getting there yet. Then there is the FFT, which we are in the process of understanding using our library, because one of the purposes of our library is to make effects easier to develop, but another is to learn about DSP. That's why I'm doing almost everything from scratch and doing it on the stream. So we are in the process of understanding the Fourier transform. We are in the process of understanding the FFT. And it so happens that the FFT is actually implemented in JSFX. It already comes with REAPER, so this is mostly an exercise to understand what's going on. But if we were to call this FFT that comes with REAPER, it also cares about the boundaries. It also cares about memory alignment. And then convolution also cares about memory alignment. And then memcopy. This is a function that we are using to copy the circular buffer that is collecting samples into an array that we plot on the screen. So we are using this memcopy and we are not considering the memory alignment issue. So the results may be undefined. And when they say undefined, it means it's junk. It's whatever is in memory in that position, or whatever crazy value that Reaper happens to have on hand. So I implemented this copying of the circular buffer collecting samples into the array that we plot on the screen. I implemented this copying on the last stream. Very painful, right? Like it was like 3 lines of code, but these 3 lines took me a lot of time. Super painful to find all the indices. And then we copied and it sort of works, but it's not taking into account the memory alignment problem. And I believe that's where the bug is coming from. So as a first attempt to understand / solve this issue, how about we don't use memcopy and we implement this the naive way, which is to just traverse the circular buffer and copy values one at a time into the array. And that's fine, because it's not the issue that circular buffers and array can, and in general, cannot cross this memory boundary. It's just that if you want to use memcopy, or if you want to use convolution and so forth, then you have to be aware of the alignment. But if you don't use memcopy, then it's fine to have the memory unaligned. And in fact, we should be saving some resources and not plotting as many points in the array. In fact, we don't need as many points. We are collecting something like 2 seconds worth of audio, if I remember correctly. We are, how many samples are we collecting? Delay lines, maximum, what is this maximum? It is 1 second. We're collecting 48,000 samples. So we are plotting 48,000 lines. One of these drawings has 48,000 lines. That is superfluous. It's completely unnecessary to plot 48,000 lines here, because this region occupies what, 800 pixels? I'm drawing the same pixel thousands of times. So it's super wasteful to do it the way that we are doing it. What we should be doing is we take 48,000 samples, which is the size of our circular buffer. We do some sort of decimation. We are going to remove some of the samples in there and only store a subset, maybe 800 samples. And then those 800 samples we plot on the screen. So maybe doing this downsampling would be a more reasonable strategy, but that seems like more work. So the naive thing is to just copy everything. And to copy everything, there is no way to use memcopy, because we have 48,000 samples. 48,000 samples is not going to fit in, or is it? Oh, yes, I guess this one fits in 65,000 samples. So that one will fit. But if we had a circular buffer of 2 seconds, which is completely reasonable for a delay plugin, then there would be no way of using memcopy, at least not one call of memcopy, or 2 as we have here. We would need to have multiple calls to memcopy, and we would need to be aware of the boundaries and copy only in the boundaries. It is something useful, but it's super annoying too. So what we are going to start with is the simplest thing that may work, possibly, hopefully. Hope it works. And it goes like this. We make a copy of this function and we change its implementation. We're not going to change anything about the way you call the function, and we are not going to change the results of the function. We are only going to change the way that the function does its job. So we do need the index from the circular buffer. Maybe not. Yeah, I don't think we will need the index from the circular buffer. And we don't need the signal from the circular buffer. Well, we need its size. But I guess I'm going to rename this. Last stream, I realized that if I am careful with my namings, I can pretend that I'm using the pseudo objects in JSFX, which is like the more idiomatic way of using JSFX. And I decided to go with real objects. There is a whole discussion about this in previous streams. In any case, it goes like this. Circular buffer signal, size, and data. I don't need to get a hold of the data explicitly, but I do need to get a hold of the data in the array. So that sounds fair. And then we are going to write a loop. So I will need some sort of index. And it's going to start at 1. No, it's going to start at -1. Then I'll loop for this many times. And I'll increment the index. So at this point in the stream, people who have been following probably are familiar with this material, with this style. I'm just looping over all the indices in the circular buffer. Then I am going to do going to set into the index, into the array, the value that is coming from the circular buffer. So let me find the circular buffer get function. I'm doing it like this just so I have the names of everything so I don't misspell something, because if I have a typo somewhere, it becomes annoying to find it. So the circular buffer that I'm interested in is this one. The offset is going to be minus the index. So this is going to start at 0 and go up to minus the size of the circular buffer. So that's a simple loop. And I mean, compared to the time it took me to write this function, this is a piece of cake. Hopefully it works too and it solves the bug, and then it will prove that memory alignment was the issue. But if this proves that memory alignment was the issue, then we have another issue, which is this is probably going to be super slow. But we'll see. Okay. It is not happy about line 265. Oh. Okay. It was just a silly little syntax error. Oh, so the circular buffer test is not passing, which means that we made a mistake in the implementation. We do have tests for this, which is great because it caught our mistake. So let's see what the mistake could be. Let me find this test first. Here it is. And then what do we have in this position? 113. Oh, I see. So I'm doing it the other way around. It's probably going to be 112 on this one. And it's probably going to be 111 on this one. Nope, it's actually 0. Isn't that something? Fun stuff. All right, so there is an issue here where I want this to go from right to left in both the circular buffer and the array. So I'm copying everything from right to left. So what I want to do is to get a hold of the array size. Well, the array size, I'm assuming to be the same size as the circular buffer, so I can do just this. And then I'm going from right to left. And then this line, or this part, kind of resembles this part. which I like. I like this similarity. Let's do a full compile reset. Let's actually remove this effect from the track and redrop it on the track. Still not passing. What could be going wrong this time? Trying to find the tests for the circular buffer. It's kind of hard to find this test. Give me an hour or two and I'll find it. Okay, here it is. So this is evaluating to 0. That's no good. This is 112. That is good. And this is 113. So that is good as well. This 0 is probably an off by 1 error somewhere. Oh, here it is. It's not an off by 1 error. It's just a variable that I forgot to rename. Okay, I think I get it. I think this is it. This is gonna be the one, guys. Check this out. Oh no. Damn it. Did I save? Yes. Now I have to find the freaking test again. No, same issue, still 0. Oh, this is 111? Okay, that's different. This is 112. I think that's different, isn't it? I think it's different. Oh, I think I need a -1 here. Yeah, this size -1 minus the index. Yeah, off by 1. Very typical, very common mistake. All right, so good thing we had those tests, because if we didn't have them, then I would be like, oh, confident that whatever glitchy thing we see on the screen was because of the memory alignment or what have you. So let's try this now. Okay, it is still flickering. It is still doing weird glitches. It is still affecting the left channel a little bit, and it's still flickering all the same. So nope, it seems like memory alignment may have been an issue. But there are the other issues. That's too bad. I'm going to leave this implementation enabled for now, because at least it's fast enough for us to see on the screen. But this is no good. And at least I am ruling out the memory alignment issue. You know what? Another thing I want to see is the code that I wrote to actually print this on the screen. So let's have a look at that. We are looping over the number of channels. That seems all right. Then we are converting into an array the delay lines at channel into the delay lines array. And you will see me selecting something and then trying to find it. That's just to see the number of occurrences. If there is only one occurrence, then I made a mistake. Then in terms of drawing the graph, I am passing the array and the coordinates. The width is okay, but the height, well, the width is actually not okay. This is all right, this is all right too, but it doesn't occupy the whole screen, which is weird. I guess this was supposed to be 400. And then in terms of height, it is also being weirdly small. But it was supposed to be it was supposed to be 300 tall. Oh, but if my screen is 300 tall. That's not gonna fly, is it? So I need to make it 150 tall, which means I have to have this as 130 because I'm leaving 10 pixels above and below. Well, if I'm doing that, then I should be doing 10 plus. So that's the padding on the top. And then this. I guess I will write this 150 as this, though. It does make things a bit slower, but I think it makes things a bit nicer too. I'm trying to be more explicit about the padding. So you have the initial padding, then 130 plus this, the bottom padding plus the top padding of the other one. All right, and eventually we may have like a padding variable here to extract these 3 number 10s on this line. All right, now at least we see the 2 waveforms on the screen, which is great. It seems like this is a bit quieter than before. I don't know. Maybe I'm just speaking more quietly. Maybe I'm intimidated by this whole issue we are having. Now, the weirdest thing is that this is affecting the sound. For it to be affecting the sound, I think that either this is like so slow that some frames are being dropped, but I don't think that's the case. I really think that the case is that there is some other kind of memory corruption going on. And if you go somewhere where you shouldn't be and you're writing and reading to memory, that is gonna blow up. So I think there is some sort of memory corruption, and memory corruption in our setting is like devastating because it affects everything and it's super hard to track down. And it can be coming from anywhere. If like I have a typo here, then bam, I'm already corrupting memory. So, yikes, that's not a good place to be at. Let me check something here real quick. Yeah, so I was thinking that maybe next we could like cheat and not continue working on this problem because this problem seems complicated and annoying. Well, I'm going to give something else a try. But if it doesn't work, I'm going to bail and work on something else. But what I want to see is this loop where I am copying arrays and everything. I also want to check how the delay lines are being used elsewhere. All of this seems correct. Yeah, everything about this seems okay at first glance. Yeah, I cannot spot any mistakes, but there is one thing that I want to try, which is I think that the issue started when we started doing this loop and having multiple delay lines. Previously, we were plotting only one. I think it was when I started plotting things that things went wrong. So I'm going to try to just plot one of these. Well, I do have to copy things over. And then I won't have a channel, so I'll just multiply by 0 at this point. So this is me just plotting one of the channels, the left channel. And I think that the issue was not happening when I was doing this. Let's see. It seems like it's not happening. I don't see any weird lines, and I don't see any audio glitches. The left and right channels are in alignment. And we are storing samples from the left and the right to do the actual delay. I mean, this is an actual delay of 1 second, so check this out. See, you see this meter? It went back up after a second. So that is an honest to goodness delay of 1 second, and it is multi-channel. All the audio routing is multi-channel. All the audio situation, let me check. Oh, I freaking know what the issue is. And memory alignment may be an issue, but that has nothing to do with our issue. Oh man, I think I know what this is. So remember how I said that the GFX block runs at the same time as the sample block? This is not the case of the other blocks, okay? Serialized block, init block, all these blocks run, as far as I can tell, they run exclusively, but the GFX block and the sample block run at the same time. So if you have a variable with the same name, it is going to be the same variable in both blocks. Page is something that has the same value everywhere. Let's go over this and check every variable. And I know that the channel variable is the one to blame, because if we are running these two loops, this one and that one at the same time, that will not be good because we have different values of channel and they start stepping on one another. So I think that's probably the issue. Let's review all the variables we are using and maybe we'll qualify them somehow. Yep, let me commit what I have. Though it's kind of junky, but I will commit what I have because I want to have a clean slate for this one. It's going to be a massive change. So channel here, I want to qualify because every variable that is a global that needs to exist both in the sample block as well as in the GFX block, I will need to qualify. Like this. I am namespacing the block, the variable. Though this name is not really special. It could be bananas.channel. Just specializing that. And then the sample here, I don't think I have a variable called sample below, but I may have a variable called sample below here, and it may be annoying for me to keep track of all of this because if I introduce a variable and I don't notice and I have a big program, it's gonna do something weird like the thing that we are seeing, and it would be super hard to track. So maybe the convention that we want to establish is that we have some global variables and we may not need to have a namespace for global variables. Like delay lines is a global variable and it may be fine being a global variable. But something like sample is not a global variable, it's a local variable. So maybe I will have a sample. It becomes kind of weird because the variable name happens to be the same as the block name, but this is a coincidence. So I think I will call this sample instead, and sample delay line. Then sample channel, that is our loop, sample channel, that's our loop. Delay line and sample need prefixes. Old sample needs a prefix. Why do I assign this to a variable? I don't need to do that, right? I could inline this. But okay, I gave this a name, that's fine. And then our sample, that's this guy. And why do I assign this to a variable? Well, it's not really necessary. But okay. I guess it's more explicit this way, which may be why I wrote it this way to begin with. Okay. Then page is global, RMS is global. Okay, I am considering having a global namespace. So I established this convention of naming global variables with global dot in the beginning, not to be confused with there is this special variable called underscore global. And this is available anywhere, including in other instances. This is not the same. My global namespace will not be the same as that. Yeah, but I think this is going to be a good measure. I will have something like that. It even helps you read the thing, I think. Yeah, whatever. Moving on, so sample channel, number of channels, sample channel, byte filter, filters. This is a global sample channel. And then this is global, and this is global, I suppose. Now let's go here. All of these are globals. Then I think we are safe to bring back the loop, because I think I'm going to have a working thing now. So all these channels are now GFX channels. Anything else? No, I don't need to change anything else. Then on this discrete Fourier transform page, this page is broken, so I'm not too worried about it, but let's go over it as well. So our data is going to become a GFX data, GFX size, GFX X and Y. Well, GFX most of these things, including that guy. This is a global, comes with REAPER. These are specific. Data is specific. Data size is specific. The index. Then this whole situation. Lots of local variables on this one. Then the thickness index. And I'm pretty sure that I made some mistake in renaming these things and I forgot something, but it is just the nature of the game. Maybe we need to establish a convention that is a shorthand, because we do see a lot of GFX all over the place, but yeah, it is what it is. So I did this fairly carefully. I think I'm going to commit this and just give it a try. It's clipping from the get-go, so that's not good. But check this out. The visual glitches are gone. That's good. The sound is bad. The thing is, if I forgot to rename a single variable, then that variable kind of already exists. Its value is 0. Everything is out. All the bets are off. Let's see if I can find some. There is a telltale thing, which is like, oh, there is a delay line variable with a single reference. So this is the number of references to a certain variable in the code. And if a variable is only referenced once and its value is 0, it's probably because of a mistake somewhere. So let's find the delay line again. Well, this is our guy, isn't it? Oh no, this is the ley lines plural, so that's not our guy. This, and that, that's our guy. Well, this is actually on the sample block. Let's see if we find a few more. We're looking for single references with a value of 0. Well, if I forgot to rename something, it's not gonna be on the GFX namespace. Index with a single reference. Let's look for index. Here we are. This is wrong. Crux02 is here. Hey, great to have you here. And they ask, is there no type checker validator linter for the JSFX files? Not that I am aware of. I consider actually implementing this myself, but there is very little in the way of static analysis in JSFX. If you try to call a function that does not exist, then Reaper is going to tell you. But other than that, there is no notion of types. In fact, a type checker would be sort of weird because all the variables in JSFX are numbers. They are floating point numbers, all of them. But the issue is just that you can, as the programmer, can assign some meaning to some variables like my circular buffers, my arrays, and so forth. And maybe we could have some sort of type checking for those. I actually consider doing a type checking thing, but it would need to be not in JSFX proper, I don't think. I think it would need to be in a higher level, like some language that compiles to JSFX. And then for validator and linter, yeah, absolutely. I think we need those things if you want to get complicated with the JSFX. But at the same time, doing this kind of low-level programming that we are doing is painful, no matter what you do. I think we nailed this. It looks fine. And it sounds fine, hopefully, maybe. I don't know. And the CPU is not that bad, so copying things over in the GFX block seems okay. I think we did it. Yay! Awesome. I'm happy. That makes me super happy. Let's double check that we have no... I'm gonna call this orphan references. There is only one reference to these guys. That doesn't seem right. That is true. There is only one reference to these guys, but everything is working, so... let me just look for X. Well, X is no good because GFX, so let's look for Y. Oh, I think I see one here, so let me rename that one. I think that's the only one. Oh, no. Here's the other one. There you go. I really was making a mistake. Now, those happen to really be zeros, but you know what I mean. There was an issue there. So now there are two references to this guy. In fact, I got into the habit of always removing everything and trying again. Like dropping the effect fresh on the track. I think that is helpful. So let's double check. No orphan references. This is okay. Everything with an underscore is from my library, so these guys only have one reference, but never mind that. It's fine. It is great. And I named everything in my library with an underscore namespace, so it appears after everything that you write. Oh, there is a section for named strings. I didn't know that. Great. We got this working. So why did we get into this in the first place? It was a long while ago. We kept doing stuff to be able to visualize things, and now that we are able to visualize something, I need to take a step back and remind myself of what we wanted to visualize in the first place. We were working with DFTs. We were working with discrete Fourier transform, and we were doing the discrete Fourier transform, but we couldn't see exactly what was going on. Let's see what the state is right now. It's affecting the performance very bad. I mean, this is super slow when I go to the discrete Fourier transform, but it's not showing me anything. And this still shows a glitch here on the right, which I think I fixed, so what gives? Yeah, let's go back to this so it's not consuming a lot of resources on my machine. And let's go to the discrete Fourier transform page and look at the code real quick. This call to, oh, we copy and pasted a bunch of code. Yeah, yucky. This is super bad. Let's review this. So I'm supposing that the DFT implementation is right and the visualization is wrong. So let's see what we have here. I think I can remove all of this. This was me copying and pasting an old implementation of the graphing thing, but the graphing thing now works with good old arrays. So I can just use it on the result of the DFT. All right, what array do I want to plot? Probably this one. At 0, 0, width of 300 times GFX x to retina, height of, I think we went with 150 for the other one, so I'm gonna do 150. Oh, but there are no, yeah, I think I'm gonna go with 150 for this one. So it's gonna be similar to this actually. Yeah, let's borrow some code from there. Let's see. So I don't need these lines. And I actually don't need this. This is an array and this function works with arrays. So I think that's that. Let's also plot the phases. And this is wrong. This should be a 0. This should be a 1. Let's give this a try. Okay, we see flat lines. These are a bunch of zeros. That's not good. And there is a glitch here on the left. So maybe they are not all zeros? Is this something? This is kind of a glitchy thing, but it could be the result. Weird. I was expecting the result to be more like a spectrogram kind of thing. Okay, let me move on to another page so I don't do something super slow all the time. And let's review. So I think we need to go one step higher with this. So how about we have 4 plots? How about we have 2 plots of the real and imaginary before we call this transformation, because maybe the transformation is messing things up. So I will do DFT real and imaginary. And then on plots 2 and 3, but they cannot be this large. So let me replace this 130 with something like 50. What is the height of my window? Is 300. 300 divided by 4. That's 75. So I'm gonna do 65, and all my paddings will be paddings of 5. Okay, so 65 of height, paddings of 5. This is plot number 2, plot number 3. This is plot number 1. This is plot number 0. This is the magnitudes, the phases, the reals and imaginaries. Yep. Let's check this out. Okay, so there is stuff happening here for sure. But it seems like maybe the issue is in the conversion from this into that. And these numbers are bigger than -1 and 1, as one would expect, because they are the addition of a bunch of zeros. These numbers are additions of a bunch of numbers between -1 and 1, so it's kind of expected that they overflow. But then these numbers are not right, so maybe the issue is in the conversion. All right, let's check that out. We are using this function. Let me split the screen. So below you will see me using the function, and above you see the definition of the function. It expects reals, imaginaries, magnitudes, and phases. And this is called DFT real and imaginary, magnitude and phase. You know what? This name is wrong, isn't it? It should be reals and imaginaries. So let me rename it. I think that this will be a clean rename. So reals and imaginaries. All right. So let's try the split screen thing again. Reals, imaginaries, magnitudes, and phases. Then we get a hold of the reals data. These are all arrays. Imaginaries data, magnitudes data, and phases data. All of that still checks for me. Yeah, right. And n is... Oh, this is not a circular buffer. It's just an array. And then our k goes from 0 up to n minus 1. And then the magnitude at k, the phase at k, calls magnitude. Oh, and maybe I should have variables for this to save to memory dereferencing thing. Couldn't hurt. Oh, no. So I have my cursor over there, and I can do it like this. And then here I can do it like this. Now this is such a trivial optimization here that I'm doing. I'm not even sure this is a good optimization, but who knows? Maybe I do think that memory dereferencing is more expensive than allocating a variable, especially a local variable. I think that local variables should be optimized anyway. Don't know if they are, but they should. All right, so we fixed one mistake. Maybe that was the mistake. Let's see. Oh, would you look at that? We have some Fourier transform, I think. Now the phase is crazy, especially because at these frequencies we have so little material that the phase is just like near 0 all the time. And then you just get a bunch of noise, and that's a kind of expected. So maybe I will not plot everything else. I'll just plot the one that in most frequency analyzers is the one that you care about, which is the magnitude. And would you look at that? This is a freaking spectrum analyzer that we did from scratch with our bare hands. This is amazing. Let me put a sine wave through this. See, a sine wave. Oh man, this is beautiful. Of course, the scale is all wrong because I'm doing this linearly instead of logarithmically, but never mind that. Let's see this go across the spectrum. Oh man, this is beautiful. And there is some sort of glitchy thing going here. I don't know. Oh man, this is beautiful. We did a freaking spectrum analyzer from scratch without any previous implementation of FFTs and whatnot. This is beautiful. This is one of the most beautiful results we had in a while. Why is this sign jittering? You mean these spikes and the fact that it's like wobbly? I don't know. Does it happen in the lower frequencies? Oh, I think I know. Yeah, it might be because of the sign that repeats and has a jump at the end of the window. It might be, yes. There are many things that we are not actually doing that a frequency spectrum analyzer should do. One of the most important, probably the one that is causing the issue, is that you are right. So in the sine wave, I have a sine wave here, but this period of the sine wave does not exactly correspond to the period of the discrete Fourier transform that we're plotting. So we may have a window that starts here and then has a bunch of cycles but ends like here. And then the Fourier transform works in blocks, and it thinks of the block as this thing that is going to repeat infinitely to the right and to the left. So the DFT actually works with a periodic signal. It means that from the DFT perspective, there is a jump from here to there, because this is where the sample ends, and then there is a jump back to the beginning. And this jump is a high frequency material, it's a low frequency material, it's some material that should not be there. The solution for this is something called windowing. So you put a window, and this window is going to remove the amplitude of the values in the beginning and the end, so you will have a zero crossing. The first sample will be zero, the last sample will be zero, not in the original signal, okay? But before you put the signal through the discrete Fourier transform mechanism that we have built, you just you multiply your signal by this window, and the window is going to guarantee that the first sample and the last sample in the window is going to be zero, so that there is a zero crossing between one period and the next of the Fourier of the signal that the Fourier transform is analyzing. So maybe the problem is the window. Maybe a quick hack to test for this could be, let's look at the period of our Fourier transform, because I forget. We are doing 2048. So if we are doing 2048 samples, oh, Bo is here. Hey, Bo, great to have you. I don't know if you missed this, but we managed to weed out all the bugs, and we got a frequency spectrum analyzer. Look at this. It's a sine wave, and I can sweep it across the spectrum, and it's super glitchy, super jittery. There are many issues to solve. I'm, in fact, explaining one of the issues, but it is a freaking sine wave that is showing up on the spectrograph. And this is me speaking, and you can see the frequency of my voice. And when I do something that is sibilant, you can see it over here. And this is in a linear scale, so you won't see much material over there because this is like from like 7 to 8K onwards. But never mind that, it's a frequency spectrum analyzer that we did with our bare hands. This is like freaking amazing. All right, so as I was saying, windowing may be an issue, but if windowing is an issue, we can do a cool trick to check to see if the windowing is causing this glitchiness. The trick goes like this. We have a window of 2048 samples. So let's pick a frequency so that there will be 2048 samples worth of cycles, and then there will be a zero crossing. I'll have to do some math to get this, but let's try to do this. All right, okay, so let me react to this. So Crux02 is saying, if the window is the problem, there should be one frequency where the artifact doesn't show. Exactly, that's my idea as well, and that's what I want to do. So I have to do some math to do this. I want a window that is a multiple of 2048. So maybe I will have one cycle that is 2048 samples. A cycle that is 2048 samples, what is the frequency of that? Well, yikes. I think I will write an auxiliary function for this. But I will have I'm just thinking that maybe I should have like frequency to samples and samples to frequency. Should have auxiliary functions for this. I think they would be useful. But in any case, what is the frequency of 2048 samples? I think I either have to divide by this or the other way around. This is a frequency of 23.43 hertz. Well, I do see a spike here in the beginning, though it is very subtle. You can barely see it because it's touching the screen, but there is a spike there. And then you still see the glitchiness. So let's try another multiple. Maybe we can get an integer, which could be nice. So let's try like times 10, and that's not going to be an integer. All right. 375. Okay, I still see the spike, but I still see some glitchiness. So maybe the window is not the issue, or I did the calculation wrong and this is not actually something that is a multiple of the window. Yeah, I have a window of... This is my sampling rate. If I divide by that frequency, what do I get? 128. And 128 is a power of 2. So that is correct, actually. 128 is a power of 2. So there will be 16 cycles for every DFT window. Oh, but this is not that easy, actually. It's not that easy because I will have a zero cross. Okay, so the sine wave is now, if I get the beginning of the sine wave on my window, I will get the end of the sine wave as a 0 as well, and that will be a zero crossing, right? That will be a zero crossing, that's great. But there is no guarantee that I'm getting the beginning of the wave. I may be getting it here. Oh no, but if it's a multiple of the cycle, then I will get the end here as well. So it will not be a zero crossing, it will be a 1 crossing, but it's not going to be a discontinuity. So that's not the issue. Maybe the window is the issue, I just cannot see it. Maybe something else is the issue, maybe the calculation is wrong. All right, let me answer this and I will be out of here. Is this analyzer based on the DFT code you wrote? Yes. This thing is not using any code that comes with REAPER in terms of calculating FFTs or plotting graphs, which is not something that comes with REAPER. But the truth is we are doing everything from scratch using bare mathematics here. So this is a spectrum analyzer that we wrote based on the DSP guidebook. So yeah, this is actually something that we developed from scratch in the stream, and it works. I'm perplexed that this is the case. So that's all for today. I see you again tomorrow. I hope that you were actually able to see this, because it's saying that I'm offline, which is kind of weird. But then OBS is saying that I'm online. I don't know. Maybe this end is going to be glitchy. I see you again tomorrow. We'll continue working on this library. Thanks for being here. Bye.